Good day, ladies and gentlemen. Today's topic for discussion is GPS fundamentals with Leica RTK GNSS setup. My name is James D. Kingery. Discussion topics are main components, how it works, functions of use. Main components of a Leica RTK GNSS setup. Leica GS14, also known as GPS receiver. Leica CS15, also known as data collector. Leica GLS30, also known as carbon fiber GPS rover rod. And finally, we have our Leica GSR111, also known as bipod. Here is a full setup on your right. Leica GS14, also known as RTK GNSS receiver. Here are the components. You have A, your connector for your antenna, B, your battery slot, C, your LED indicators on off button and function button, D, you have your LEMO port, which is your special data transfer cable port, E, you have your mechanical reference plane placed where the rover rod connects. Moving on, we have our Leica CS15, also known as data collector, and this is the keyboard. At the top of the screen, you have the screen on top of the data collector. The only thing we'll add to this, because there is a lot and I don't have enough time to go through this, but letter D is your function button. You hold that down in order to press anything that is in green. So if you want to use your letter G or your letter O, hold down that function button. Leica CS15, also known as data collector, bottom. This is the bottom of it. The most important thing is USB port. This is where you import data and export data. So if you need to import reference points for a construction layout, you will do it through here. And once you're done and you collected those points, you want to export it through there as well. Same as you want to export your data from a topographic survey. You want to export your survey through there with a USB data stick. B, you have your power socket, C, you have your LEMO port, and D, you have your docking station contacts. Here we have our Leica GLS30, also known as carbon fiber GPS rover rod. Here are the components. A, you have your carbon fiber rod with snap locks at 1.8 meters and 2.0 meters. B, you have your bubble level for gravitational plumbing. C, you have your threads for insert into bottom of GPS receiver. Leica GSR111, also known as bipod components. A, we have our legs adjustment buttons. Press to release legs for extension or retraction. B, you have your two adjustable legs. C, you have your rod attachment bracket. Very simple. How it works, GPS versus GNSS. GPS, also known as Global Positioning System, uses two different types of components for accurate predicted coordinates. These components include a GPS receiver, for example a phone, and satellites that orbit the Earth. These satellites are constantly transmitting data back to the Earth. The data they transmit includes accurate time and location of the satellite. The GPS receiver compares the time the data was sent to the time the data was received. So in turn, this time of flight can be used to accurately predict the GPS receiver's location. Here's a diagram on your right that explains it, and there is my source on how I got the satellite pictures. How it works, GPS versus RTK GNSS continued. Okay, now we're moving on to RTK GNSS, also known as Real-Time Kinematics Global Navigation Satellite System. Essentially has the same concept as GPS, but is more accurate. This is due to an added component from the RTK and extra satellites from the GNSS. Basically, the receiver gathers data transmitted by the satellites and corrections from a reference station based off a known point on the Earth. A known point, if you don't know, is essentially a specific spot on the Earth that has public recorded coordinates. Everyone knows what they are. It has a horizontal data and vertical data, elevation, that is public records and everybody knows about it and can research it and find it. Moving on. Functions of use. How can we use the Leica RTK GNSS setup in today's ever-changing technical workplace? For one, we can use it for construction layout, aka stakeout. Is a process where a survey crew goes to a construction site with a set of RTK GNSS equipment and puts reference points in the ground. These reference points are usually nails. Moving on. For whoever is building said project, these reference points are based off of prior calculated coordinates that were based off a set of plans for said project. The reference points usually consist of a brief description of what is being referenced and possibly an elevation of said reference point. That is usually used for cut and fills. Here is an example to your right of a roundabout that I had once done with stakeout, and it has reference points on it. Here's another example of functions of use for the RTK setup. We have a topographic locations is a key component for making three-dimensional maps, and the Leica RTK GNSS setup can do it. Three-dimensional maps are vital for civil engineering, design, and confirmations on already built projects. Due to the higher accuracy of this setup, a surveyor can easily locate and store three-dimensional data in the onboard data collector. So our conclusion, main components of a Leica RTK GNSS setup was covered today. How the RTK GNSS setup works in comparison to the typical GPS was covered today, and the different functions of use in today's ever-changing technical workplace was covered today. Now, if I have any questions, comments, or concern, please let them be known now. Thank you very much.